Hello, and welcome to the AI IoT Hub. Great to have you with us today. I'm here without Paul. Paul's been dragged into really important affairs for Lenovo, so I'm continuing in his absence. It's probably going to be a temporary absence, but we'll see. Work pressures are against him at the moment. So I'd like to thank the sponsor, Newcastle University, and the Edge AI Hub for sponsoring these community events. Really much appreciated. Happily, I have a new hostess who's going to join me, Rajni, who has an extensive background in the IoT space. Tell us about yourself, Rajni.
Hi, good evening all, and thank you, John, for inviting me. Hi, I am quite new to AIoT Hub, but not so much to AIoT as a topic itself. So the bulk of my last 15 years has been predominantly in this space. I was trained as a wireless engineer. So working in the last 10 years at Sony Semiconductors and prior to that at Fujitsu, typically I have been involved on both the server side of things, but mostly the sensor distributed networks and AI and IoT at edge. So there are loads of stories I've accumulated over the years. Hopefully, maybe I can share one or two in coming months. But for now, I hand you back, John.
Great, thank you, Rajni. Yeah, so I can see quite a few people have joined us. I'm John, one of the hosts of the IoT Hub. Paul's away, and Rajni is coming to help me host and ask difficult questions to our speaker, who is Suyash. So Suyash is from InfluxDB, developer advocate there. We've had talks about agricultural IoT before and a few community talks, but your takes a very topical AI slant to things. So should be quite interesting.
Yeah, I hope you will find it interesting and everyone else. And I'm looking forward to your questions as well in the end.
Cool. So just to let you know, in May, we've got Federated Edge Intelligence for Decentralized Smart Grids. Aditya Thakakar is presenting that. So you can sign up on one of the meetup websites, and then you've got Responsible AI at the Edge, the talk that got postponed from February by Professor Dhaval Thakur. So that's two interesting talks. If anyone's got any talks they'd like to share with an extensive IoT community of 10,000 members and broadcast live on YouTube and get stored on YouTube, please get in contact with either myself or Paul. Great, thanks. So over to you, Suyash.
Thanks, John and Rajni, and welcome everyone. This is my first time at the AI IoT Hub, and I'm thrilled to be amongst the 10,000 people who are part of the community and the very many people who are joining today. And this will also be recorded because it's being streamed. So if later on you have any questions, please feel free to get in touch with me. I'm on LinkedIn, Twitter. You can easily find me. I also share my contact in the slide. And with that, let me share my screen. And let's get going. So today's topic is automating plant care with AI and IoT. This is somewhat of a personal pet project. However, it can also be applied, the technical side of it, the infrastructure, the technologies are very much applicable to industrial IoT that can be farm tech or ag tech, etc., etc. So our agenda is as follows. I'll try to be on time and leave time in the end for questions. But if you have any questions, comments that come to your mind, please type them up in the chat, and later John and Rajni will feed that to me. So we will talk about real-time IoT pipeline, because that's where it starts. How do we process this data, which would be our sensor data from our plant? Then I will show you the physical plant demo, walk through the code as well, and we will interact with it using AI, which is going to be our favorite LLM, Claude, and then finally questions and answers. I work as a senior developer advocate at Influx Data, and here is my contact information. If you have any questions, please email me anytime. So it's the age of instrumentation, and I think I'm preaching to the choir. You already know the impact of IoT, especially in the current age where we have smart vehicles everywhere, smart buildings, smart machines, robotics are becoming more and more popular, as well as everything that is monitored, and we have observability for our software infrastructure. That could be networks in a data center, financial systems, especially in London. I meet a lot of people who work in large banks, and a lot of automation is used. But behind the automation, it's critical to instrument, collect the telemetry. Also, example are smart cars, autonomous vehicles. Now, these can be vehicles that are, driving you around like taxis, but also robots. These robots, some of them might not be this beautiful looking, but they're robots in the plant, in the factory floor that are working autonomously, right? Can be robotic arms that are sorting things, or robot that moves around as a security or monitoring, or even drones, right? For good or bad, drones, and a lot of this infrastructure is heavily autonomous, and all of that generates a lot of data. Now, this data has a few characteristics, and here are a few more examples. So if we look at the graph here, the three graph of different type of data, because the data can be from sensors that measure your heartbeat, can be from temperature sensors, and then, like I mentioned, can be software metrics. Let's say if you are a DevOps person, or you want to monitor, your infrastructure, software infrastructure. One of the key characteristics of this data is that the data can be regular or irregular, right? As you can see, if we plot it, it has a graph that goes up and down. It comes continuously, generally, it's streaming. And one of the key characteristics is that time component. And that's generally in a graph you would see on the x-axis. And time is very critical, because if you want to, let's say for here, you want to know why there was a spike in, a heartbeat, or a spike anomaly in the temperature reading. The time gives us the information. What time did that happen? For how long did that happen? And from there on, we can do further analysis and come to a decision if some action needs to be taken, if this was something one-off, or there is a serious problem that might occur here. And of course, here I've also put an image of a flight airplane, which has millions of sensors, and they generate huge amount of data. And this, very applicable right now. I should put the image here of a satellite or a rocket ship. As you can imagine, the current news in space, where NASA launched this rocket where astronauts are circling around the moon. And if you see in the mission control, they're collecting so much telemetry data, and the data is monitored to the millisecond. And all of that is very essential, because they want to know anything is, if there is anything wrong, especially before anything big happens. So some characteristics are, this type of data has a timestamp. It comes in regular or irregular. We call them metrics or events. Generally, it's huge volume, high frequency, and it comes in real time. It can also come in huge bursts, but generally the data is always, being emitted by these sensors, right? And when we measure them, there's different type of time horizon. If you are launching rockets in space, you want to go to probably the smallest time interval and want to know everything, right? But if you are just, monitoring your plant, you probably just want to know at every second, right? Or every minute or every hour. So depending on the context, the time interval changes. And such data we call time series data, and it's seen everywhere in IoT, especially industrial IoT. The data can be, like I mentioned, machineries in warehouses, uh, green energy systems like solar panels and battery monitoring, or even home automation, right? Like plant care is one, but if you have other sensors in your home monitoring temperature, monitoring, detecting motion, etc., all of this is time series data. And this data, it comes in huge volume. So one of the challenges is how do we ingest this data that can be streaming in large volume. Data also needs to be saved and stored for various reasons, for compliance, for historical analysis. And because this data is coming in, let's say 24/7 all the time, it can become huge. So we need a system where we can store this in a optimized manner. Another aspect of this data is called cardinality, which is how wide is the schema, how many, for example, columns there are that we need to store in the database, because that's a critical factor when you determine how do we process this data, how do we store it. And then, of course, we want to know the real-time metrics, real-time analysis of this data, right? Again, if you're monitoring, factory automation, or you're monitoring, space launches, you want to know in real time. And to do that, when the data is stored, the question becomes how fast can we query the data? And you want to query it very, very quickly so that you have real-time analytics. So such data can be stored in different type of database, but generally there is one type of database that is optimized for that. And I think you've gotten the hint. But just to paint the picture, databases comes in different forms and different sizes and different types. The oldest of them is the relational database, which the example would be Oracle or MySQL, Postgres, which are great for relational data, such as like if you want to store data about your customers, if you have a business and their transactions. Another type of database is document storage, which is really optimal to store data that is unstructured, such as if you're talking to AI tools, all those chat messages, it's best to store them in a document store such as MongoDB, because it's not optimal for relational database or any other type of database. Another one is Elasticsearch, which is optimal for having data where you want to query data, when you want to do search across different fields very quickly. And finally, data that is relevant to all the aspects we talked earlier, such as timestamp data comes in bursts, streaming data, regular, irregular metrics, high volume, and you want to know real time, query the data in real time. And that's optimized for a time series database. And that's InfluxDB, the company I work at. We make that product, InfluxDB. Our latest version is InfluxDB version 3.9. We are very proud of it. It is open source, both open source and also commercially available. So it comes as MIT license, and an enterprise version, you can also buy it. So just to give you a little bit what this database does, because this is the core of our demo, and it's heavily used in IoT. It's a time series database that's essentially a columnar store engine. It's built in Rust on top of a lot of popular open source technologies, such as Apache Arrow Flight, that basically provides the columnar data engine. The Apache Data Fusion, which is another very popular open source project that affords SQL as our default query language. Apache Arrow, which keeps data in memory. Parquet, which is a file format optimized for storing a lot of data and easy to move around. Parquet, very popular format. So all of this is underneath InfluxDB. And it is designed for high volume, real-time data that is optimized, that is stored for fast queries, and it integrates with data lake houses, etc. And this is a pipeline that could be set up in an industrial setting. So I know a lot of the audience member here are professionals, so I'm sure you're familiar with this. Those who aren't, I'll just walk through some of the components here. So for example, if you have, let's say, this plant monitoring system in a farm, you would have various components and various sensors deployed across, your plant, right? Where you are collecting or where you are measuring data about, let's say, you're doing hydroponics and you're growing various vegetables and fruits, and you want to know the status of all of these, like, what is the moisture level, what is the temperature, etc. In industrial setting, a lot of this is done with the different type of edge devices. So examples would be PLC controllers, or SCADA is a very popular format. There are different type of machineries that have their own proprietary format, different sensors, robotics, etc. And that is where the data is generated. And then the data is streamed generally, and that comes in different formats as well. So MQTT is one popular way to stream the data from the client to basically to the server where you are storing the data. Another way you can send data, very popular, is Apache Kafka for streaming data, Modbus, another protocol, and then other proprietary protocols as well, Siemens S7, etc. And in this stage, there is a very popular tool that is used, that is also built by our company. It's called Telegraph, and it acts as an agent. It can collect data from different formats, different machineries, because it has a lot of these we call plugins, and they are open source project. The whole project is open source. The plugins are open source, and they can read data coming from a Modbus queue or MQTT client or a Kafka, or you can even write data in CSV, like offline, if you want to dump data, and Telegraph can read that, and then it has plugins to take in the data and then also to spit the data in a particular format. So if you are writing data then to InfluxDB, it has a plugin that can convert the data from this format to the format which we store data in InfluxDB, which is what we call line protocol. And then there are other middleware tools as well that you can use, or directly. In my demo, I'm going to use directly our client library. So you can use directly the client. We have client libraries for different programming languages. So our demo, I'm going to show in Arduino, which is C code, and we have a C client library that you can use and write data directly from the device, which is Arduino, and it's reading the sensor data and then directly sending it to InfluxDB without Telegraph, this is just multiple ways to do that. It's the flow. And then finally, when the data is in the database, we store the data, we query the data. And there is another new feature in InfluxDB, which is data processing engine. This is a unique offering in our latest version of our database, which is a Python virtual machine, which enables you to do any kind of data interaction, I should say. So for example, you can write a piece of Python script that can run whenever the data is coming in. And for example, you can monitor, let's say, temperature value from your sensor. And if the temperature value goes above a threshold, you can, Python, we call them Python plugins, which are these Python script that runs inside the database. So you don't have to have a separate Python server to do that. All you need to do is write inside of Python function that we provide your logic, and we have a lot of examples. I'll show you that. So you can monitor temperature, and if the temperature value goes above a certain threshold that you can define, you can send alerts. All of this can be done right in the database, so everything is done real time without any external complicated architecture. And then generally a common stage is that people want to create a real-time visualization. So there are a lot of projects for that. Grafana is one very popular project, or Apache Superset, or Microsoft Power BI, etc., etc. And sometimes we also see people want to take this data and they want to take it to a data lake, such as Snowflakes or Databricks. And we have integration where you can bring that data to a data warehouse, and then you can do offline AI machine learning on that. Or you want to connect the database to an AI tool, which we will see today, Claude, and then talk to the data using that in natural language. So let's look at the demo. And for that, I will stop my screen share so you can see in full view. So you can see myself. I'm in my living room where I have my little setup right here. So here I have my plant. This is the bonsai plant, and it is connected with this. If you can see this, I have another one here. So you can see clearly, this is a capacitive soil moisture sensor. And it has 3 wires coming out, and they are connected to the GPIO ports of the Arduino. And this Arduino board is a more powerful Arduino. It's R4, and it has a Wi-Fi chip in it. And here, one of them is providing power to the sensor. Another one is ground. And the third wire is for analog data, because this is an analog sensor. All it does, it collects the soil moisture. It monitors the moisture level of this plant, because the use case here is I travel quite a bit and I'm out of home. And then, we have the common problem. We want somebody to water our plant, right? We don't want them to die. It's a nice bonsai plant. And right now, the setup is it monitors the soil moisture. And if it drops, I have a way to send an alert to myself. Next step is that I have here a little cup of water. I have here a water pump, simple hose, and this is a module that connects with the water pump. And this, I will have it connected in a little bit. I just got this recently. So I will be putting this all on GitHub. Current project is on GitHub, but not with the water pump. But what this will do is, so the hose on one end with the water pump, this is the type of water pump that can be submerged inside the water. So it then monitors, all powered with Arduino. It will monitor when the soil moisture goes below, let's say 50%. Then it will take some water, and through this hose, it will put some water in the plant. And then again, I'll monitor because I'm monitoring continuously, and then it'll stop. So it would be a self kind of like take care of the plant, because it already sits by the window here. So the sunlight, it's taken care of. But another addition I want to do is put a light sensor, so I can monitor the light, and also a DHT11, which is a temperature sensor. So I can monitor temperature, even though it's in my room, which is it's controlled temperature. But just to add some more sensors, have more fun with this. So let's have a look now. I'm going to switch from my camera. We're going to go back to the slides. And let's have a look at our screen. So here I have, this is the Arduino code. That's the heart of the program right now. So here I have a few things. So I'm running InfluxDB on my laptop. So right now you're seeing this is my Mac, and you're seeing Arduino. Now this Arduino is not connected to my Mac because it has a Wi-Fi board and it's sending data over the Wi-Fi. So I don't even have to be in the same place. I can be some other country, some other city, and I can get the data here. But right now I'm running everything locally, so I'm on the same Wi-Fi network. But Arduino, it's at home, connected to my internet. I don't have to be here, but just wanted to make that point, because right now I'm showing you a Wi-Fi example. You can also do this same thing with MQTT. And this code is also on, this project is also on GitHub. This version uses MQTT protocol, which is more, and this is our MQTT topic, and we send the soil moisture data. And I still need Wi-Fi to connect to the internet, but the way I'm writing data is using MQTT. And I have an MQTT broker that runs on my Mac, and this is our MQTT client. In this example, I'm using our client library. So I'm directly writing using HTTP protocol to the database. So that's the difference. It's much more straightforward. And here, I'm just checking everything with the network. Inside the loop, which is the main function in Arduino, we read the analog sensor value from this pin AO, which gives us the value, the raw value that the temperature moisture sensor it is sending. The sensor collects value in analog. Arduino has a built-in analog to digital converter, and I'm reading the value in analog. Then I'm doing simple math to map that value between 0 and 100. So if it is dry or wet, it's a big range for the analog values, but I want it to be more meaningful, so I convert it to 0 and 100 values, adjust them, and then basically I'm printing them out in the serial monitor, and then I write that to the database. To do that, I have to convert this data into a format called line protocol. That is a very popular format now in time series databases. It's innovated by InfluxDB, and that's the format in which you can easily read what it means. So here, basically, this is the name of the table. This is, we call it the name of the tag, which is the metadata. So it's telling I have this device and I have this at this location. So it's key value data. And then I'm appending it with other things, which are our field values. So I'm also providing it another key value pair, humidity percent. Here I'm providing it what the actual moisture percent is, which we calculated it right here. And then the raw humidity value as well. I'm storing the raw analog value as well. And all that I say send to InfluxDB, and this is the function that connects to the database. So it's very simple and straightforward. And using InfluxDB client library, everything in C makes it very simple. So right now, this program is already running. This is the log values that we can see. It's 77%. And I have here also running is InfluxDB. So I have InfluxDB, I'm running it in Docker, and it's running on localhost port 8181. And the database has a UI, which is running on localhost port 8888. So if we go back to my browser, we go here. This is the database UI, where we can interact with the database and we can see everything and monitor it. And here I have two databases, plant health and soil data. And it has 15 tables that got created. And these are internal tables, and then user-generated tables are 2, and then here 1. And I'll show you both of them. So first of all, let me just query the data. And to query it, InfluxDB likes SQL, so we can write here, select star from the plant, I believe it's this. And something is, oops, no, so from the table, which is, so the database is plant health, and here are the two tables. So if I click this, and I can just remove the where clause right now. So if I run this, you can see all the values. And here I can select past 5 minutes, and I can see the values that are coming from the device, and through Arduino, it's being written to my database that's running on my local laptop. Again, the database can also be running on the cloud. You can put it anywhere. It's, I'm using our open source database. It's very tiny. You can also run the database not on an Arduino, but you can run it on a Raspberry Pi. So for example, if I connected the soil moisture sensor to a Pi, I could just do everything on the edge. So the database can run on the Pi. It can store all the values there. And then I can run another instance of the database, let's say on the cloud, and then connect those two, because very common use case to save all the raw data on the edge, and then some data we want to put it in the cloud, right, as a backup or for other teams to access. So right now, here we can see the current data. And just for fun, I'm going to let me stop this sharing. What I'm going to do is, just for fun, because I want to prove it's real time, I'm going to water this plant. So it doesn't need a lot of water. It's pretty good right now, but just put little bit some water, and let's see if the soil moisture reading changes. It should, because the sensor is very sensitive. So we go back here. It's hard to do a live demo with a physical on the, so bear with me. We're going to go back to the database, and if I query, let's say past 1 minute, as you can see, the moisture level has jumped up from 77. This is the current timestamp in UTC. So it's the current GMT time, which is 1 hour behind, and 91%. So we are loaded with water right now. So the plant is happy, and I don't have to water it for some time. But as you can see, the sensor is very sensitive. The data is being written every 10 seconds. So I'm writing data to it every 10 seconds, and we can see the timestamp here as I'm writing data to it. Some other things I wanted to show you that I have going is, I talked about plugins. So in our database, we have built-in library of these Python programs that we call plugin, and you can use them as is. You can modify them, or you can create your own plugin, which is your own Python program to do anything with the data. So for example, I have here a plugin that is called downsampler. And all it is, it's a Python file, downsampler.py. You can copy and paste this code in your IDE and edit that. You can download the code. If you are happy with what it's doing, what it does, it basically takes the data and it calculates the average of it. It aggregates the data, certain attributes of the data, and then it downsamples that. So the data is right now collected at every 10 seconds, but let's say, that's fine, raw data, but I'm interested in saving data every hour interval, right? And I can query for that, but I can also create a new table where I can downsample all the raw data. Raw data can be in one table, and I can downsample, and I can say, save all my data, downsample, and you can run this plugin at a given schedule. So I can say, run it every minute, and this would be the source measurement is the name of the table where the raw data is. What is the name where we want to downsample the data? It's create a new table. We call it every minute. And window, here I'm saying, let's just do every 30 seconds, or let's just say every one minute. And I can deploy this plugin. And now it will downsample the data. Instead of every raw data, we're going to see data at every 1 minute, what that looks like, the aggregate value of the sensor of the moisture. So here we come to the dashboard. Here we can see our logs. So this is showing the logs from the Python program. It's saying 1 record written, and it's calculating continuously. It's downsampling the values. This is one example. You can do many, many things. some other interesting things. You can do machine learning, very simple statistical actually approach to calculate an anomaly. So this is very popular in industrial IoT. If we have a sensor, we want to know when there was an anomaly in the data. And to do that, this is a Python program that detects anomalies, and we can install this. This would not be a good example because the soil moisture sensor data is not changing. It is very, it's consistent. The moisture doesn't drop very quickly. But for example, let's say, we were talking about spacecraft, or let's say a motor that's spinning, right? Or some other sensor that changes values very quickly. And you want to know if there is any anomaly, any irregular spike in the data. And this plugin does that. It detects anomaly. So you can use this. You can also use Kafka subscriber. So if you're sending data, Kafka messages, you can use this to subscribe to a Kafka stream. Similarly, we have an MQTT subscriber. So you can send data like you saw my Arduino program. This acts as the MQTT broker, which subscribes to the MQTT topic, which is the data coming in as MQTT format. We have other plugins where you can send notifications. So if you want to send a notification like alert on Slack, SMS, WhatsApp, etc., you can use this plugin to do that. So a lot of these built-in helpful functions that you can just plug, or if you want to create your own, you can create your own as well. And so that's the Data Explorer. Now we can run this again and we can see the data. So if I read the latest values, it is I'm wondering why the data has come back, why the humidity value has come back to 79. Wait, I think this is okay. This is there are two databases. So let's just look at the raw value. Let's check all of these columns. So we can also write our SQL query by checking these boxes. And if we do that, for some reason, the moisture percent, perhaps it settled down and it wasn't as much water as I thought. It went up from 76 to about 79. So I haven't poured so much water. Probably most of it just fell around here. But as we can see, the water level did go up and it is settled at 71 right now, which is fine. And the other thing is we can also save this. And if we want to see this data more in visualization, we can also see simple visualizations here. And if you want to create more fancy visualization, very popular tool that we recommend people integrating with is Grafana. You can have nice dashboards using that. So the other thing I wanted to show is integration with the AI. And there are two types of AI. Let me just kind of walk through a little bit of the slides here. So we saw something like this right now. Soil moisture written using Arduino to the InfluxDB. And then I showed you a processing engine plugin where instead of alerting, we are doing downsampling of the data. Next, I'll show you how we can talk to the plant using LLM. But here I also wanted to mention that here we are using Arduino because it's a hobby project. But in the industrial setting, you will use something more standard, which would be like a PLC controller at the edge. And this is the MQTT. This is probably the more interesting slide. Here we can see the comparison between two approaches. So right now, for this example, I'm using directly HTTP to write the data. Because this Arduino board has Wi-Fi chip, However, if I was in an industrial IoT setting with multiple edge devices, then I would go with the MQTT setup. And MQTT, we can use Telegraph, or we can use any kind of MQTT broker, because MQTT client is the one that sends the MQTT data using MQTT protocol, but we need a broker as well. With direct HTTP, we don't need an intermediary broker. We can write directly to the database. The benefit is that it's a more scalable approach with MQTT, because here we have a linear setup, client to the server. Here we can have multiple clients to one broker. And these clients are these edge devices. And there are other benefits as well. So in terms of buffering, there is none. If the DB is down, we have broker queue messages. Data is buffered if you especially leverage Telegraph, which is an open source tool that has a MQTT broker where you can if, let's say, the sensor goes down, it has a buffer where it saves the data, and then when the sensor comes back up, it continues that buffer from there on, so you don't lose the status when the connection went down. And this is an example of an MQTT setup. The big concept here is temperature value. There's a publisher and there is a subscriber. Subscriber is our broker or the server. Publisher is our client. And the way it sends data is an MQTT protocol, which there is a thing called topic. And then there is the payload, which is the actual message they're reading. And then the data can then be, so my MQTT broker is running on my device where I can read the data, or it can also be on the mobile phone. This is an example of what the topic, if we did this with MQTT, would look like. So the MQTT topic is a protocol that looks something like this. It's a hierarchical protocol. So here I've defined basically the data is coming from a plant that lives in my living room, which is inside my home. And then example of the value of the actual temperature. And here we convert this to a line protocol, which is how we write to InfluxDB. So that is the second step we have to do. And if you use Telegraph, or I showed you the MQTT broker plugin in the database, it automatically does this behind the scenes. So you don't have to worry about that. And this is line protocol to give you a little bit idea. It's just a format, how InfluxDB writes data. It's very readable. First element is the table name. Then there is a key value pair, which is we call tag set. Then we have a field set, which is where the actual value is. And then finally, we get a timestamp. And timestamp is something automatically gets added if you don't provide that in the line protocol. And the AI part is, so right now we have, the traditional approach. I'm just collecting some data and I'm writing it to the database. A more smarter way would be if I would run a edge ML model that could perhaps, in this case, the use cases are limited. Big use case in IoT is predictive maintenance. And to do that, the one big thing is model is very popular is to detect anomalies, like I mentioned earlier. Or another use case is forecasting. And then models these days are so small now, tiny models, that we can run on the edge to do that. And that is shown here. So predictive maintenance is a big area in industrial IoT. For this plant, not so much, because the values don't change that often. So generally, it's very easy to forecast what the plant's water level would be tomorrow from a historical perspective. If the plant doesn't need water, every day it's going down by 5%. Maybe it's hot right now, 10%. Then after a week, maybe you need to water the plant. But if there is some other kind of a sensor in an industrial setting that may break down at some point, it's efficient to forecast it and to take measures before that happens. And the other common use case for AI is anomaly detection. Both of these you can easily do, and the heart of that is model that runs on the edge, and the model has to be trained on time series data. So that is what all of the data that basically lives in something like InfluxDB. And I mentioned processing engine plugin, which are Python programs that you can run inside the database and to do various things like data processing, alerting, forecasting, etc. And I showed you the UI where all these plugins are, but all of them actually are inside GitHub repo. And if you click these, you will see the Python programs, and you can contribute your own. You can run the plugins using our CLI. Right now, we did using UI. So the plugin can be on your local machine. It would be a Python file. It needs to have one function inside of it, and you would create a trigger to run that plugin. We have a whole course on how to do that, a deep dive training. If you're interested, I'll show you that at the end. But here, the point is, we can use these plugins to do machine learning on the edge, right in the database. So everything happens almost in real time. And we don't need to create a separate setup with a separate Python server, etc. And then the other thing is, let's go to Claude. So I'm going to go here, Claude, and I'm running Claude desktop. So this is your Claude that you would access on your phone or on the browser. And I'll say connected to InfluxDB. So what I've done here right now, I have connected Claude to InfluxDB using InfluxDB MCP server. It's very straightforward to create this integration. You can connect it to Claude and other popular LLMs, and I'll show you. So this is my local, everything is running locally. This is InfluxDB 3 core, which is our latest open source database. This is our InfluxDB UI. This is the UI tool that is running on local, we saw on the web. And this is the MCP server. All of these come in Docker images. You can also download these InfluxDB without Docker directly as a binary, but I like Docker because it makes life easier. And the MCP server, this is running locally, and it's connected to, it's a very simple configuration how you connect your Claude to an MCP server. I've connected to InfluxDB. It's telling me that localhost is data, and say, what is the data that is inside? Tell me tables. So using natural language, I don't have to know SQL. I can just ask it, tell me about the database. So it's telling me you've got 2 user database, soil data, plant health, very nice. And it's going to check the tables inside of it. Nice thing is that we can see everything that Claude is doing by clicking here. And you can see the queries that it is running. It's run this query, get measurement tables, and then it returned different tables. And here it got one database, and then it got the other database, and then it saying it found 3 measurements inside this database. Measurement are our tables. So here it tells you, I got this, it has 1 table, and I got this, which has 3 tables. Super. Now I can ask it, tell me the table, how many columns it has, all of that, right? But the nice thing is, because this is AI, I can just ask in natural language. I think it's smart enough. Just tell me, how is my plant doing? Do I need to water it? And Claude, because it has a smart LLM, it will understand the natural language, translate into, code, and then it will execute SQL query behind the scene, and it gives me the result back. So here it says it's pulling the latest reading. The plant is doing just fine. 77% is the moisture that is sent from the Arduino, blah, blah, blah. 70 cells healthy. When the soil drops below, you want to urgently below 20-30%. So that's good. And then it's telling me other information. The nice thing is that we can see here the actual SQL it executes. So it ran select star from our table where all the raw data is stored, order by time, and it's showing the last 5 values. So it's smart. And then it gets the response back, and it executed another query, which is now it's checking the humidity value every minute. And it's doing the min and the max function in SQL, also calculating average. Very nice. So I can ask it, tell me average value of moisture and how bad was it any day. I just started this program like today, so it's not going to go way below what we saw already. So let's just see what it comes back. But here, what we are seeing is that we don't need to know fancy SQL functions. You can rely on natural language. You can I'm running it here. You can use it on your local machine. Everything local. So right now I'm running Claude, but if you run a local model, let's say Olama or a local LLM model, offline open source model, you can do everything. Technically, you can do everything on a Raspberry Pi, everything on the edge. Right now, everything is happening on my laptop or on the Arduino. But this Claude, see, it created a nice graph as well, which is very nice. That's the beauty of LLM, that it can explain to us however we like to be explained. So this is great. It says the moisture level did shot up to 98%, and then it settled quickly in the 80s. So that was just the sensor calibrating down. So that's great. And go back to the slides here. So this is what we saw. Basically, the MCP server is the middle layer. Claude or any kind of AI assistant translate the natural language into SQL. MCP server basically enables it to talk to InfluxDB, and then InfluxDB returns the data, right? And this is connected to the Arduino at the edge, which is writing data every 10 seconds. So to configure, if you want to connect MCP server to, in this case, Claude, very simple. You have to edit the Claude setting file. It's a config.json, and you have to provide the database, basically port and URL. I'm running it on Docker, so this is it. And you have to provide the database token so it can talk to the database. And the rest of the stuff you can leave default. That's how easy it is to run this thing, and you can talk to it. And that's it. And if you have any questions, please contact me anytime. This is our company's community Slack. We have a lot of people do hobby projects. There is another very popular project called Home Assistant. We have community members like to share. So if you're doing anything for hobby or for work, love to hear. And if you want to learn more about everything I talked about, go down. We have a university course, and this whole project is on GitHub as well. So back to Ragni and John.
That's great, Suyash. And welcome to Marleyman 101 in Scotland and Miguel from Spain. So Suyash, so just to summarize, you've got some telemetry gathered in Arduino, which is doing an HTTP post to your InfluxDB running on Docker. And then I love the MCP example. Everyone's doing an MCP server these days. To fantastic effect. It seems to be the interface that works for everything now. Great. If anyone's got any questions, please put them in the chat, and Suyash can respond live. I just had one question. It's that whether Influx supports Iceberg schema format, because I think that's becoming quite important for your data lakehouse.
Yes, great question. Yes. So we do have an Iceberg integration. Very popular request has been from one of our customers who wanted to take data to Snowflake, and Iceberg integration enabled that. So we have that. It's with InfluxDB 3, which is our new version, because for that, another critical thing is Apache Parquet. That is a format that we also support. So that makes transporting data from one place to other easy.
That's great. So Marley Man asks, will this be uploaded so we can rewatch? I'll definitely go through this again with my own project. Yes, the URL you're currently viewing it on is the URL you can rewatch on, because everything's saved to YouTube, and including our back catalog.
While we wait for other questions, I have one for you, Suyash. You mentioned about InfluxDB being optimized, or predominantly being time series database, but there are applications where an IoT architect may have to combine unstructured streaming data with time series, either temporal or tempospatial data. In the context of, let's say, agri-tech, there might be a use case where a camera is at the edge and collecting photos to make sure that there isn't a disease sign of any disease, for example. So in this particular scenario, what would you advise? Does this integration have to take place at application layer, or is there a possibility of combining or pulling over this unstructured data into Influx, because you have this inbuilt Python processing as well, which technically can get rid of application layer? So how would one approach this?
Yeah, it's a great question. We have a lot of customers who combine us with other types of database. So for image, very common is a vector search database, which are optimized, for RAG. And so you would not store, we wouldn't recommend images in InfluxDB because it's a binary data and it's not optimized. So InfluxDB has certain data types you can store. So you can convert that binary, put it as a string, but then you have to reparse it. And then it's better to have it in its own ideal database, which could be even Amazon S3, or RAG database, and then convert that into a vector and then do your so the Python programs that I was showing are more optimized for time series data, because these are base for numbers or strings or integer these values. But the type of machine learning on the vision is more done ideally on images, which are these vectors. So but what we had one integration, the way they did was at the application layer, you would write something like a SQL query that joins across different databases and different tables. So you can, through the camera, you can see the leaf, it's getting going brown, and then you can correlate that with the sensor value of the moisture and how long the water level was low, and then you have two data points to say there is disease or something. So one would keep them separate, but you would do that logic in the application layer. Yeah.
And maybe an extension of the same question, if alternatively this type of edge vision data or video data were to be converted into time series data by just processing at edge what's going on and then generating, well, at whatever timestamps that this is going on, is it possible to then import that kind of data? So it's not coming directly from sensor, but it's coming from a different database. That API is possible.
Yes, because then it becomes the prediction, the output of the data from the vision models. Then you can store that. Yeah, those are just strings, numbers. You can store that, with the timestamp, and then you can do whatever queries or on that. Yeah, certainly.
Okay. Thanks.
That's great. So that takes us to 7 o'clock, and we are at time. Should we see your robot destroyer?
If there is time, I would love to come back.
Yeah. Well, we've always got time for a robot.
Cool.
This is the AI IoT.
Physical AI. I've been getting into physical AI, and sensors and Arduinos are great fun, but And I also encourage you to next level, start playing with robots, because I think it's becoming very popular, especially IoT crowd. You're at the right seat on the table of robotics that is becoming mainstream now. So I ordered one. It's a small robot imitating the Boston Dynamics robot. And I hope to come back in the future and share this with you. And it's a robot dog made by a Chinese company, but it's quite sturdy. And it has a lot of sensors and actuators and motors. It has a robot arm that can grab things, camera, everything is running on a Raspberry Pi, believe it or not, at the edge. A lot of edge, like we were talking vision models, etc. And it can do a lot of things that more sophisticated these Boston Dynamic robots do, but in a smaller scale. So hope to come back and show this, and we can learn more about robotics. And so just wanted to give a little teaser today.
So that's great. Thank you, Siyash. I'm sure we can have you back at some point in the future to do a talk about the robot. I personally have always got time for robots. So next month, we have Federated Edge Intelligence for Decentralized Smart Grids in May, and Responsible AI at the Edge in June. Maybe we'll have Siyash back in July. So it just leaves me to thank Siyash for your excellent talk, and Rajni for helping me host and with the insightful questions. And I hope to see you all next month.
Thanks a lot. And also, Siyash, brilliant talk. Thanks a lot.
Thank you both. It was a great pleasure, and hope to see you all in future.